improving named entity translation in neural machine translation systems. First, let's look at background to our research area. What is neural machine translation? It is an approach to machine translation that uses an artificial neural network to predict the likelihood of a sequence of words, typically modeling entire sentences in a single integrated model. When translating, we are encountered with phrases that distinguish one thing from a group of things that share the same characteristics, such as a person name, a location name, a phone number, etc., which are called as named entities. To translate these named entities, first we have to recognize them. Here we have an example that has labeled named entities by their categories. In this example, we can see named entities related to four categories. They are person, location, organization, and miscellaneous. Well, this brings us to the question why we need to improve named entity translation. Named entities in a sentence are very important and must be correctly translated. As an example, here we can see a translation of the sentence. මම ඊයේ උඩුවට ගියා by Google Translator, but Google Translator has failed to correctly translate the proper noun උඩුව, which is a location, leading to a difference in meaning between original sentence and the translated sentence. And here we have a translation from English to Sinhala, but as we can see, named entities have not translated into Sinhala correctly. So we can clearly identify the motivation of why we need to improve named entity translation. This illustration summarizes the approaches that we can use to address the task of translating named entities. There are two approaches, transliteration and translation. Transliteration of named entities is the process of converting words from a source language alphabet to a target language alphabet while preserving its phonetic and orthographic features. But the issue is that transliteration only works for some cases like Nugegoda. But if we consider Mount Lavinia, transliteration does not work, it should be translated. Also, when translating named entities, it should be considered within the context of the sentence. If we consider the sentence, here green is a person name. So transliteration is okay. But for the other sentence, green is a name of a color, so it should be translated. Therefore, in this case, transliteration would be a problem. The best solution we found in the translation approach is the method proposed by Professor Junji Hu. Their attempt was to address the problem of translating named entities in medium and low resource languages. Nepali was used as a low resource language, however, as the results table shows, they have failed to get a good performance on Nepali language. So we can identify that Professor Junji Hu's approach has failed to address the requirement of a better translation scheme to translate named entities in low resource languages. Further, Sinhala language is also considered as a low resource language, and translation of named entities in Sinhala language has not been attempted before. Well, this brings us to the motivation to do our research. So let's look at our research objectives. Our main objective is to increase named entity accuracy by improving an existing named entity recognition system, and by using that we hope to improve a pre-trained language model using a new pre-training objective for Sinhala language to enhance named entity translation.
Let me now move on to our methodology. The primary focus of our research is to improve named translation performance on Sinhala language, which is considered as a low-resource language, in order to address the lack of an accurate translation methodology. This method primarily focuses on the application in low-resource setting, as in the pre-training method, they use monolingual target language data to improve named translation for low resource and medium resource languages. Therefore, we use that method as our baseline. The baseline approach basically consists of two main parts as pre-training stage and multitask fine-tuning. Prior to the pre-training stage, in the entity recognition and linking phase, they recognize name entities in a monolingual corpus and link them to knowledge base like Wikidata using Sling Entity Linker. Then they extract named translation from the knowledge base to construct noise sentence from the original sentence. Then they pre-train their NMT model to reconstruct the denoise original sentence from the noise sentence. They have looked into multitask learning strategy that fine-tunes their NMT model from both denoising task on monolingual data and the translation task on parallel data in order to prevent knowledge learned from the pre-training stage and as a further improvement for the NMT translation task. This figure illustrates our whole proposed approach. In our research, we considered neural machine translation between English and Sinhala languages. Let's look at what happens through our approach considering only one sentence from the monolingual Sinhala language dataset. Now let's consider this sentence as the original sentence. First, during the name method recognition and linking phase, we recognize name entities in sentence using existing name method recognition system. And then we link it to a knowledge base to replace recognized name entities by their translations. Here we use Wikidata as our knowledge base. But after this phase, this gives us the partially noise sentence. But there can be more name entities that are not translated during this phase. So we use another technique such as Google Translation API and transliteration approach to translate remaining name entities to get the further noise sentence. After that, we pre-train the model to reconstruct the denoise original sentence from the noise sentence. Then we carry out the fine-tuning task as in our baseline.
Now let's look at how our approach differs from the baseline. In the baseline, Sling was used for name entity recognition, but at the moment Sling supports only 25 default different languages excluding Sinhala. So we assume that Sling is not performing effectively with Sinhala language. Therefore, we use the NER system in our approach, which was done as a FIP by a last year's group. It was specifically implemented for Sinhala and English languages. And also in our approach, we carry out a further noising step prior to the pre-training. For the pre-training task, they have used training from the scratch, but in our approach, we use pre-trained language models for pre-training. As I mentioned in the previous slide, we carried out the further noising step prior to the pre-training because due to the limitation of named entities in Sinhala Wikidata, there can be remaining named entities after linking to the KB. Therefore, we use Google Translate API and transliteration approach to get translations of those remaining named entities. We did various experiments on using translation API and transliteration approach as follows. In NER plus KB linking plus Google Translation API and transliteration experiment, we performed transliteration only on remaining NEs that were categorized under person and location and translated other remaining NEs using Google Translate API. As for the NER system that we use for any recognition, we did various experiments using various pre-trained language models and used the model that gave best results in our experiments. The results we got from our experiments are shown in this table. This table shows the details of datasets that we have used in pre-training and fine-tuning tasks. Now let's look at results we got from our experiments. As shown in the table, first we find that NER plus KB linking plus Google Translation API plus transliteration surpasses all other methods. As we can see, fine-tuned random model gives better results than the fine-tune after pre-training with Sling. At the moment, Sinhala is not there as a default language which Sling is implemented for. So this may be the reason why pre-training with Sling gives lowest results than the other methods. In particular, Our proposed approach that uses NER system obtains a substantial gain of 9.53 blue English to Sinhala translation. Second, we observe improvements with the usage of additional techniques like Google Translation API and transliteration approach. The usage of Google Translation API as an additional technique to NER plus KB linking has shown an increase. Entity translation accuracy also shows the same variation as the blue results. Next, we carried out experiments using embarked CC25 model in the pre-training phase. Since the trained XLMR model gave improved results, we used that as the NER system for all other experiments. Here we were able to improve our results by increasing data in the pre-training stage. After that, we did experiments using embarked 50 model in the pre-training phase along with the same NER system and increased dataset in the pre-training phase. First, we pre-trained the model on embarked objective and then pre-trained on both embarked and deep objectives. Research shows that pre-training the embarked 50 model on both objectives gives best results of all the experiments we have carried out. Finally, let's look at our conclusion and future works. We hope to recreate the proposed approach for Tamil to English and English to Tamil and Sinhala to English. And also, we hope to improve the pre-training phase by using new objectives. Thank you.